So let's come to the 11th question. Water falls from a height of 60 meter at the rate of 15 kg per second to operate a turbine. So turbine is a device that generates electricity. Okay, and it converts the kinetic energy of the water into electrical energy. Okay, the losses due to the frictional force are 10% of the input energy. Now, how much power is generated by the turbine? It is being asked. So first of all, you should understand that the gravitational potential energy of the water is being converted into the kinetic energy, and that kinetic energy is 90% converted into electrical energy and 10% is wasted in the frictional force. So what is the gravitational potential energy that is being lost by the water? It is mgh, and 90%, which means 0.9 times the GPE, is actually converted into electrical energy. So now 0.9 times 15 kg per second, right? 15 kg multiplied by G, and the H is 60 meters. Now this value comes out to be 8100 joules per second, which basically means 8.1 kilowatt. All right, so the first option is the correct option. All right, let's come to the 12th question. The effective resistance of a parallel combination connection that consists of 4 wires of equal length equals equal area of cross section and same material is 0.25, which basically means if there are 4 resistors in parallel like this, then the equivalent resistance is R by 4, which basically means this is 0.25 ohms. So the value of R becomes 1 ohm. So the value of each resistor is 1 ohm. Now what will be the effective resistance if they are connected in series? Now if each of the resistance is connected in series, which basically means 1 ohm, 1 ohm, 1 ohm and 1 ohm, then the equivalent resistance would be 1 plus 1 plus 1 plus 1, which basically means 4 ohms. So the correct option is the third option. All right, let's come to the 13th question. Now match the column 1 and column 2 as and choose the correct match for the given choices. Now the root mean is square speed of the gas molecules. Now we know that this is root 3 RT by M. The pressure exerted by ideal gas. Now we already know that the pressure exerted by the ideal gas is 1 by 3 into total number of molecules, that is Nm times RMS velocity square, which is basically V mean square. All right, root mean square by square. All right. So the average kinetic energy of a molecule is obviously 3 by 2 Boltzmann constant times T, and the total energy of 1 mole of a diatomic molecule, since the degree of freedom of diatomic molecule is 5, it comes out to be 5 by 2 RT. The value of N is taken as 1 over here. Okay, so the correct option is A to Q, B to P, C to S, and D to R, which basically means the second option. All right, now let's come to the 14th question. A particle is released from height s from the surface of the earth. At a certain height, its kinetic energy is 3 times its potential energy. The height from the surface of the earth and the speed of the particles at that instant are respectively. Now let's take this example that the particle is traveling from a height s and is released with the initial velocity of 0. Now let us take an instant point P where particle has reached a height h. So obviously it has traveled a height of s minus h, and the potential energy that has decreased is basically converted into the kinetic energy, which has made the particle to move with a velocity of v. So what we can write is that mg s minus h is the kinetic energy. This is the decrease in the GPE, which means increase in the kinetic energy, and that is equal to 3 times the potential energy, which means mgh. Now solving this, we will get the value of h as s by 4. All right. Now, what is the kinetic energy in this situation? So the kinetic energy is half mv square, and that is equal to mg s minus s by 4. That's it. That means 3 mg s by 4. All right. Solving this, we will get the value of velocity as under root 3 gs by 2. All right. So the correct option for this question is s by 4 and 3 gs by 2, which makes it the third option. All right. Let's come to the 15th question. A convex lens, a focal length 20 centimeter, and concave lens B, a focal length 5 centimeter, are kept along the same axis with the distance d between them. If a parallel beam of light falling on A leaves B as a parallel beam, then the distance d in centimeters will be. Now let's take this example. Let's say there's a convex lens, and this is the principal axis of the convex lens. And let's say light rays are coming parallel to the principal axis, and obviously they have to converge at the focus. And the focal length of this length is 20 centimeters, which means that they are converging at a distance of 20 centimeters from the lens. Now there's another concave lens, which means that there is another diverging lens that is making the light rays to go parallel to this axis. This is the principal axis. So where should this lens be located? Obviously, this lens should be located at a distance of 5 centimeters from this point, so that the light rays after refraction goes parallelly, isn't it? So if this is 20 and this is 5, this distance has to be 15 centimeters. So it is being asked that the distance d, which is the distance between both these lenses, has to be 15 centimeters. All right. So this is the 15th question. Let's come to the 16th one. Find the value of angle of emergence from the prism. Refractive index of glass is √3. Now first we need to find the critical angle for this. So this is sine inverse 1 by √3, and this is obviously greater than 30 degrees. Now why am I writing this? Because once we get that this light ray is incident on this surface like this, and this is 90 degrees and this is 60 degrees, this obviously becomes 30 degrees. Now this is 90, this is 30, this has to be 60. So obviously this has to be 30 degree, and this 30 degree is less than the critical angle, which means the light ray will emerge out of this prism like this. Now we have to apply the Snell's law over here, which states that mu1 sine I is equals to mu2 sine r, and the angle of refraction is equals to angle of emergence. All right. So this becomes √3 by 2 is equals to sine E. So the value of E becomes 60 degrees. So this third option is the correct option. All right. Now let's come to the next question. Question number 7. A capacitor of capacitance C is connected across an AC source of voltage V given by V is equals to V naught sine of omega t. The displacement current between the plates of the capacitor would then be given by. All right. So first of all, we know that if this is the phase of the current, the phase of potential across the capacitor is 90 degrees below the current, which basically means current leads voltage by 90 degrees. So if voltage is given to us, we can find XC, which is equals to 1 by omega C, which basically means the value of I naught is V naught by XC. That means V naught by 1 by omega C, which means V naught times omega C. And obviously the value of current is I naught sine of omega t plus the phase difference, which means 90 degrees. This boils down to V naught omega C cos of omega t, and this is our correct option. So the correct option is the fourth option. So 17th, correct answer is fourth. Now let's come to the 18th question. A dipole is placed in an electric field as shown. In which direction will this move? Now we can see that the electric field lines are diverging, which means here at point A, the value of electric field is more as compared to the value of electric field at point B, which basically means that in this dipole, the value of force exerted on the plus Q charge is greater than that exerted on the minus Q charge. So the net force is towards the right. Okay. The correct option for this is towards the right, and its potential energy decreases. See, the potential energy decreases because the dipole is moving in the direction of the electric field, and we know that potential decreases in the direction of the electric field. That is why option 1 is the correct option. Now let's come to the 19th problem. So in this problem, force, acceleration, and time are chosen as the fundamental physical quantities. You have to find the dimension of energy. So we know that the dimension of energy is same as the dimension of work, which is equal to dimension of force multiplied by dimension of displacement. And as far as displacement dimension is concerned, it can be written as AT square, because the dimension of acceleration is LT minus 2, which means the dimension of displacement can be written as AT square. So the correct option for this question is option number 1. Let's come to the 20th question. An infinite long straight wire carries a current of 5 ampere as shown. If PQ is the wire that is carrying a current of 5 amperes. An electron is moving with a speed of 10 to the power 5 meter per second parallel to the conductor. The perpendicular distance between the electrons and the conductor is 20 centimeters at an instant. Calculate the magnitude of the force experienced by the electron. See, first of all, this 5 ampere conductor is creating a magnetic field at this point. Let's say this point is P. And the value of this field is mu naught I by 2 pi d, where d is the perpendicular distance from the wire to the point P. Now, the value of force is QVB, which means E times V times mu naught I by 2 pi d. Now, if you calculate this value, this comes out to be 8 into 10 to the power minus 20 newtons. If you put all the values, you will get this, which means the third option is the correct option. All right.